My name is Jozef Cvirik. I'm from a company called Ipesoft, and I would like to let you know about what we do with tools like other languages. We are a software company. We have certain products, and I would like to let you know about what this product is, how does it look like, what we do with it. And it's not going to be that technical as you probably would like to have it, but I believe that with the agenda I have in hand, I will not bore you to sleep. Okay, so Ipesoft, we are a company, privately owned company from Slovakia. We've got about 80 programmers or employees. We do some real-time application server. We programmed in an environment which allows us to create applications which are aimed at real-time data processing at industrial facilities or especially in energy management and systems which are called manufacturing execution systems. And this company is around for about 18 years now. The basic piece of the software we developed and which we use in our applications or solutions is called, or we called it D2000. It's in a way, here is the list of the standard features you would expect in this kind of software. One thing is important, and that's the first one. It's a multi-platform software. That is, we've got a single source code which is now written in Ada, and we are able to produce, run, or to compile it to different platforms, software or hardware platforms. Otherwise, it is completely open based on the system or industrial standards, so that it's, quite nice piece of software. User or end users can add their own features if they like to. We support programming on the application level. We support programming in Java, or we've got our own scripting language in. This is something which might look a little technical or more technical. The architecture of the solution is that in the middle of it there is, I don't see the light, doesn't matter. There is the kernel which we call, or which is here named as a D2000 server. And this core piece of software communicates with additional processes which have specific task to fulfill. There are communication processes, statistical, mathematical support, and there are archiving, which is a very important thing. You've got the several levels, so 3 levels of archiving. We take all the technology data real time, that's the first level. The second level we call it a statistical archive, where are data which we compute and use for certain trends or evaluations. And there are specific, the highest level of the archive we can put aside. It's not available online, but for a certain reason we need to keep certain data available, let's say for 10 years, because if these are, let's say, invoicing data, then we are, by legal, asked to keep the track of this data for a pretty long time. And then there are other processes which are transaction-based processes. They deal mainly with the databases, and there is standard DBase, we call it the DBase manager. There is an event handler, that's a software which is responsible to send certain alarms or alarm management. That is, if something unusual happens, and we are able to notify the user, either sending an SMS or email or whatever. And the third piece of it is, we call it EDA, that's Energy Data Archive. It's a specific version of a database software which is optimized to store and access time series, data which are stored with timestamps and might span, let's say, 12 months. It's millions of data. And if you want to compare, let's say, this year data with last year data, you just pick one vector or one time series, the other time series, and you might compare it, make certain mathematical operations, either sum it or subtract or whatever you like. But it takes some time, so that was the reason why we optimized this access a little bit. And now, on the right-hand and left-hand side, there are boxes which describe the standard user interface, which allows the user as a full-featured client or a thin client over the web browser to get into the data, see the data, and work with the data. Of course, the system is open, and quite often there is a need to integrate with standard Office applications, so we supported it as well. Now, typical feature of the solutions we provide on this software platform is that they tend to grow. We start with the certain pretty well-defined specifications, implement the system and let it live, and the users play with it, and it tends to grow. So the system has to be flexible enough to cope with these changes and these expectations from the user side. So there is no problem, if there is a need for that, to add additional processes and basically make the system able to process more data or be more responsive if there is a need. We have a client where we started with the system where every month 2 gigabytes of data were stored in archive every month. After 6 years of life, now we got 25 gigabytes of data every month in addition to the old one. So that's a pretty big difference, and there is still the same system. It was no changes. We added a couple of communication servers or something. That's all. Or 1 or 2 processors into the existing servers. And we can do this on fly. There is no problem with real-time reconfiguration of the application without necessity to restart the whole system. So it's pretty sophisticated stuff. Even this is not always enough, because there are certain situation or mission-critical systems where single computing center is not enough. So we support certain, we call it redundancy, so that we've got 2 copies of the servers of the application running on, let's say, geographically disparate locations, and they work in a configuration. One part of the servers is the hot server. If something happens and it fails, then it's automatically the hot standby starts to work. And from the user point of view, they have no idea which server is actually serving them. And this hot standby switching takes place in pretty short time, so they don't see it. They don't see it. There's of course, there is a message to system logs or somewhere that something happened and that this switch took place. Okay, development of this application framework or real-time application server took us quite some time, and we were in a position that our customers required us. They need long-term support. Typical lifespan of the solution I will talk about or I describe is about 6 to 10 years. So once we put it in place, it's supposed to live without any modifications, except the growing, which I mentioned already, at least 8 years, and then it's time to refurbish it or change it or do something else. So the customers really expected long-term support, reliable software system which does what is expected to do and doesn't do what is not expected to do, which is highly available because sometimes they need really systems running 24 hours, 7 days a week, which we can, with the setup of redundancy, easily provide them. And they want to have their data secure with all the access to the data monitored and logged somewhere so that it can be traced back. And it was by accident exactly the same what we needed at that time because of from the point of view of the development platform which we use for creating of this software. We as well needed a long-term support from our compiler provider. We need reliability of this key development suite which we use. We wanted to have it available anytime we needed it, and we wanted to have it to be secure. When we started, it was 18 years ago. It was written in Modular 2. The first design, it was homemade, and it's still the same. The architecture, the general ideas which I described are the same as were set back in 1993 or so. So the language of choice was Modular 2, and the operating system was IBM's OS2, which was a nice couple, and it worked. But then IBM stopped supporting or developing the OS2, and we were forced to switch about 500,000 lines of codes to port it to another operating system. So we say, okay, we will use the Windows because that was the operating system at that time, and we'll continue program in Modular 2. Which was a bit difficult because of the company that was providing us the compiler. They were not flexible. They were not able to give us reasonably good development environment. That was a problem. And that was the reason why we said, okay, we are not going any further with Modular, and we will rewrite it into Ada, which seemed to be, or now it's 100% clear that it was a good decision. But again, from the beginning, we had some difficulties with the company that we cooperated, and it was not what we expected. Fortunately, as time passed, we approached Adacore, and we started cooperate with them. Now we're using GNAT Pro development environment, and it allows us, it's a long-term cooperation. It takes really, it started about 10 years ago. So we are satisfied. I hope the people from Adacore are satisfied as well, because we got everything we wanted, what we needed, and in addition, we are able to support several hardware as well as software platforms. So we've got a single source code, and we are able to compile the code for the Unix, OpenVMS. Some of the older people might remember that there is an operating system like, or called OpenVMS. Of course, Windows, but as well on the hardware side, we are able to run on Intel x86, 32, 64-bit architecture, or on Itanium 64-bit architecture, or even on all old alpha processors. Okay, so that's about the system we have, and now I will briefly demonstrate a couple of applications we developed. On the picture here, there is an idea of a system which allows to produce power energy, sell power energy, plan production of the power, and keep all these things concentrated together. Our customer here is a company company Enel, which is Italian owner of the former Slovak power plants. That's a huge company, which is the biggest producer of the electric energy or power in Slovakia. They've got a couple of nuclear power plants, they've got tens of hydropower plants, and they've got 2 or 3 thermal plants. And for every day, they have to plan the production of the electricity on all these premises, hour by hour, based on a detailed planning or scheduling. And we were lucky to provide them the solution which is really crucial for them. And it covers all their needs, starting with the planning, with the selling and buying energy, with controlling the generators according to certain scheduling, which is agreed one day before, with all the consumers of the energy. We can compute for them how efficiently did they produce the energy. And we even provide a tool for Slovak Energy Dispatch Center, which is responsible for keeping the whole network balanced, a tool which allows them to play with the generators directly. It's a load and frequency control terminal. This business is pretty difficult because there is no way how to store the energy which is produced, the electricity. What is produced has to be consumed, and if there is kind of an imbalance, there has to be immediate reaction to that. And this system allows Enel in Slovakia to do all this in real time. It has to be real time, there is no other way. From the implementation point of view, there are not 2 redundant systems, but 3 of them. 2 of them are running in parallel, and the third one is backup, and it's used for as a testing site. In a way, when we need to implement certain changes or whatever, we try it on the third setup, and then we switch it from to other 2 sites. This is probably the most complex implementation of our solution based on our D2000 architecture. The second example is a railway energy management system, which we implemented in a cargo again in Slovakia. Railway cargo, they've got 2 kinds of locomotives. One are diesel, and the other are electric locomotives. What we actually do that inside each locomotive there is a measuring system installed. We take all the data, store the data locally, send them over the GPRS network to a central system in real time, and then we support these things like planning, consumption, optimization, and we allow them to monitor their actual power consumption. And then, as the highest level, they have a support to be active on the energy market. They have tools for risk management and these kind of things. So before they have implemented this system, they have no idea what energy or how much energy they actually consumed. By the end of month, they received an invoice and they paid it. Now they know in detail, because we've got a map, we created a map of the tracks, and we can say them on each section of the railroad track how much energy is the general amount or the average spent. They can compare their drivers, how efficient they use the energy. They can even notify the drivers, we are going to have a problem, so slow down because you are taking too much energy or too much power from, especially on electric locomotives, it's important because once you cause the imbalance that you take more than you planned, or you don't take everything you planned, you pay additional money, and this fee is pretty high. So now they know what they are doing, and they can optimize their work. This project has been awarded as a best IT project in Slovakia in 2010, in the last year. That's nice stuff. And this is how does it look. I mean, it's very easy. All you need is to have some GPS on the locomotive. You need to have some GPRS to be able to transmit quite a lot of data in real time. And if by accident you are in a tunnel and you cannot transmit any data, then you have to keep it for a time and then send it when you are again covered by a signal. It's very easy in a way. Okay, the last thing, this is the third example. We built a transit gas dispatching center for a company called Ustream. This company is responsible for delivering the gas from Russia, from Ukraine border to Czech and Austria, to Western country and to Western Europe. In a way, at the time being, it is the biggest gas transiting company in Europe. There are new pipelines being built, the Nord Stream or South Stream. So there will be they will have a tougher competition. But from our point of view, we built 2 dispatching centers running in redundancy, but they are about 50 kilometers from each other, and we basically control the whole this pipeline in real time. And based on the data which we have, then additional systems can be built and actually has been built at Ustream for giving additional data or additional information to the users. This is the oldest system. It runs on a couple of alpha machines with OpenVMS, and we plan to make a hardware platform switch for next year, so there will be some Itanium-based computers for that. But we believe that the software will remain the same, so that means that we can just recompile what we have already. We already started to do that, and we are looking forward to continue this work. Okay, that's almost everything from my side. Thank you for your attention.